right, students, I just wanted to show you a few other types of problems that go with this last lesson of ours, lesson 10.3. So the first one is just kind of want to just reiterate something about these types of problems. So I have the square root of x squared. And so one thing you could do if you want to work that out is you just say, okay, well, what is x squared? Well, I'm sorry, not x squared, 8 squared. So the square root of 8 squared, well, 8 squared is 8 times 8, which is 64. And then you could just take the square root of 64 and just put that in your calculator. What times what equals 64? And your answer is 8. But what I wanted to show you all, and so you could even work this out without even using your calculator if you just know the rule that anytime you take something to the second power and then you take the square root of that, those two are opposites of one another. This says take 8 times 8, and this says what times what is this. And so they kind of undo each other. So whenever you see something to the second power and then you take the square root of it, your answer is just always going to be your base. But you could always just work it out. But B is just like that. I have the cubed root of 6 cubed. So again, this says take 6 times itself 3 times, and this says what times itself 3 times equals this. And so they undo each other. So your answer is just going to be 6, okay? And so just notice that if you've got the square root of something squared or the cubed root of something cubed, they kind of undo each other, and you're just left with your base. Okay, and really, she showed it, like this is like saying 6 to the third to the 1/3 power. And then you multiply these. So 3 over 1 times 1 over 3 just give you 1. And so it's just 6 to the first power. And you can totally work it out like this, but I just wanted to show you that those are opposites and they undo one another. Okay, so this C, square root of 27, she showed how to do it one way, and MyLabs Plus, the helps tool, is showing it another way. And so I just wanted to show you that the way that MyLabs Plus is doing it. And both ways work, but I just didn't want you to get confused if you're seeing it. The helps tool help you out a little bit different way. She showed doing the factor tree. And this is very similar, but I'm just going to show you a different way. So what I do on this is I say, okay, I'm going to break down to 27 and say what are two numbers that multiply to make 27, and I want one of those numbers to be a perfect square. So you could list all your factors of 27. You've got 1 times 27 and then 3 times 9, and really that's pretty easy because those are the only two. And are any of these perfect squares? Yes, 9 is a perfect square because 3 times 3 equals 9. So what you can do is you can write out 3 times 9. So I just broke down 27 to write 3 times 9. Well, this is the same thing as saying the square root of 3 times the square root of 9. And again, this is how the helps tool in MyLabs Plus is going to teach it. So then I say, okay, well, can I simplify either of these? Well, I can't simplify the square root of 3, but the square root of 9 is 3. So I can break that down, and I've got the square root of 3 times 3. And that's my answer, but it always wants to put the number that's not a square root on the outside. So your answer would be 3 times the square root of 3, and you write it out like that. So just another way to do it. Again, she showed using the factor tree, and then you well, I'll even kind of show you if you want to compare. She showed doing the factor tree, and you do that's 3 times 3 times 3. You have 3 times 3 times 3, and then you take anything that's a match and you bring it on the outside. And so it's 3. Those 3's come out to the outside, and you're left with 1 3. So again, either way, you get the same answer. I just wanted to show you the other way, if that helps you out. Okay. Oh, sorry. D, this negative square root of 108. Again, I'm going to kind of show you how MyLabs Plus did it. Again, she did the factor tree. Either way is fine. But what I'm going to do is I'm going to say, what are the factors of 108? And I'm going to try to break them down. And I'm going to see if I can find one that is a perfect square. So let's do, you can do 2 and 54. Well, 54 is not a perfect square, neither is 2. And then just use your calculator. 108 divided by 3. 3 goes in there, and that's 3 times 36. Oh, that looks good because 36 is a perfect square. It has a square root of 6. And so what I can do is I can come over here and I can write out 108 as 3 times 36. And then I say, okay, I can take the square root of 36, and that is a 6. And so I'm going to bring that out here on the outside, and I'll have negative 6 times the square root of 3. That 1 3 stays in there. The square root of 36, which is 6, comes on the outside, and don't forget your negative. There was a negative here in the problem. So, again, if you want to compare to what she did your factor tree. Oh, 3 and 3. And she did, okay, that was 2 times 2 times 3 times 3 times 3. Take out the pairs. Can't pair that one up. 2 times 3 is 6 times the square root of 3. Oh, but see, then negative. See, and I had forgot. Yeah, so I would, if you do that, I would take, just don't forget the negative out here on the side. That one's kind of tricky with that negative. But you still get 6 times the square root of 3. So either way works, however you want to work it. Let's continue on to E. E is the square root of 95. So I'm going to just look and see what are the factors of 95. And you can kind of play around with your calculator. And I can get 5 times 19. And I believe that's all that works. So I look and see, well, okay, can I take the square root of either of these? Is there a perfect square of 5? Is there a square root of 5 or a square root of 19 that comes in evenly? No, there's not. Those are both prime. And so this is one of those that cannot be simplified. It's just the square root of 95. Because there's no factor of 95 that makes, gosh, I'm sorry, I think I'm shaking a little bit. There's no factor of 95 that is a perfect square. So just don't be fooled by one of the, any of those. Okay, the last one I want to show you is just one of these with some big numbers. And again, I'll show both ways. The way she showed with the factor trees, and she wrote out all the y's, and then I'll just show you both ways. And this one, doesn't really matter how you do it. So I'm going to do it this other way first. So what I'm going to do is I'm going to break this down, and I've got the square root of 144 times the square root of x to the third times the square root of y to the ninth. Again, I can just take the square root of each one of those separately and see, okay, well, what can I simplify? Well, thankfully, there is a perfect square of 144. You can put that in your calculator, and you'll get 12. 12 times 12 is 144. So this becomes just regular 12. I've got that. Okay, so then this is where it gets a little tricky, and I'll show you the other way to do it too. I can't take a perfect square of x to the third because it's odd, okay? There's no number that can multiply together because it's an odd exponent, I'm sorry. So there's no number that can multiply together to get x to the third by itself. But I can break this down, okay? I can break this down to x squared times x, okay? So I've got the square root of x squared times x. Well, now can I take the square root of one of these? Yes, just like before. I can say, well, the square root of x squared is x. So I can bring that on the outside. Okay, so in my answer, I've got 12, and this is going to have, basically it's going to have x on the outside, and then I've got an x left on the inside, and I'll just put that over there. Okay, so again, I broke down x to the third to x squared times x. I can take the square root of x squared, which is x, I bring it on the outside, and I'm left with this one inside because I can't take the square root of that. And then y to the ninth, let's break that down, okay? Well, I can write that as, again, I want an even exponent, so I can write it as y to the eighth times y. Okay, well, can I take the square root of y to the eighth? Yes, I can. Y to the fourth times y to the fourth equals y to the eighth, and I didn't leave me much room over here. So I can take out a y to the fourth and bring it on the outside, and then I've got that, and then I'm just left with y. So my answer is 12 xy to the fourth times the square root of xy. So, other way to do it, if you want to compare them right here side by side, she did 144, and then she wrote out all her x's and all her y's. And maybe this way is a little bit easier. It just can get, oops, and I can't even show off it there. Okay. It just can get maybe a little more detailed and tedious. So whichever way works, but we should be getting the same answer. So again, I can look at 144. I can take the square root of that. That's a 12. Bring it on the outside. Here I'm going to have something, and I'm going to have some left underneath, and I'm going to have some I can bring out. Okay, and then I look at my x's. How many pairs of x's can I make? Well, there's 3. I can only make a pair of 2. So I can take that pair. That becomes 1x on the outside, and then I'm done with it. But I'm still left with this x. I can't do it. I don't have anything to match that up with. All right, so then we look at our y's. How many pairs of y's can I make? Well, I can do 1, 2, 3, 4. Okay, so remember the square root of y times y is just y. So I can bring out 4 y's in the outside, and I'm left with just y on the inside. So either way, notice I've got 12 xy to the fourth times the square root of xy. I've got 12 xy to the fourth times the square root of xy. You'll get the same answer. So either way that works for you, go for it. All right, let me know if you have any questions.